My name is Dewa and in this video I'm going to tell you about my answer, my explaining my answer in my task. So here we go. Number 2, assign a point to R2 and use metric multiplication to determine the reflection of that point on where A x axis, y axis, and line y equal to x. So first is x axis, we have value 1 and 2. We answer this. X axis is x and y, that is become to x and minus y, like this. It is and we need to multiplicate it by standard matrix. So this is standard matrix of the axis, and this is standard matrix of y axis, and this line y equal to x, this line matrix. So transform from 1.1 and 2 is, yeah, this is standard matrix of x axis. We multiplication it. 1 0 times 1 is we get 1, 0 minus 1 and 2 we get minus 2. So the answer is matrix 1 minus 2 for x-axis. So next is y-axis. Y-axis is x and y, that is minus x and y. So transform 2 and 3 is this is the standard method of y-axis, and we multiplication it. Minus 1 0 times 2 is minus 2, 0 and 0 1 times 3 we get 3. So the answer is matrix minus 2 and 3. This for that is for y-axis. And next is line x equal to, sorry, line y equal to x. So or we can call it z-axis, that is x y and become y x. So t of 3 and minus 3, oh sorry, for sorry, uh, line y equal to x has the value 3 and minus 3. Yeah, so the we has we has value in each other, yeah, different value. So the value of the value of 3 and minus 3, yeah, we need to multiplication first. This is standard matrix of line y equal to x, and with that we multiplication it. 0 1 times 3 is minus 3, and 0, sorry, and 1 0 times minus 3 is equal to 3. But remember this xy become yx, so we change it, become this minus 3 and 3. So the answer is matrix minus 3 and 3 for line y, and for line y equal to x. Okay, next is number 3 is give a point to R3 and use metric multiplication to determine the result of the verification of that point again. And we need to only choose 2. So this is A, as has value is 3 2 and 1, and first we need to replication of xy plane. Yeah, same as number 2, it is we need to multiply the point with standard matrix. So this is standard matrix, both xy plane is 1 0 0 0 1 0 0 0 minus 1. So yeah, we will and we need to multiplication it. First is 3 times 1 0 0, we get 3, and then 2 times 0 1 0, we get 2, and 1 0 1 times 0 0 minus 1, we get minus 1. So we get matrix 3 2 and minus 1. So we get this answer. Next, and then about the reflection of xz plane. Yeah, we need to multiply the point with the standard matrix. So the standard matrix of plane is this 1 0 0 0 minus 1 0 0 0 1. Yeah, this. So yeah, we multiplication it. 3 times 1 0 0 is 3. 2 times 0 minus 1 0 is minus 2, and then 1 0 0 1 is get 1. So matrix, then we get TA equal to matrix 3 minus 2 1 and 1. Yeah, this is the answer. Next is number 4. Number 4, assign a point to R2 using multiplication to determine the orthogonal projection from the point to, and we choose 2. First is x-axis that has value 1 and 2. So we answer x-axis as x, and y is equal to x and 0. Yeah, the standard matrix is 0. This is standard matrix. Wait. Yeah, this is standard matrix of x-axis is 0, and this 1 0 0 0. So yeah, 1 0 0 is times 1, we get 1, and 0 0 times 2 is get 0, and then we get the answer is, yeah, matrix 1 0 and 0. We get this answer. Got it? Next is y-axis that has value 2 and 1. Y-axis is x, and y is there is 0 and y. So transform 2 and 1 is equal to standard matrix times 2 times matrix 2 and 1. So yeah, standard matrix of y-axis is 0 0 1 0 0 0 1, and then we need to move it 0 0 0 0 times 2 we get 0, and 0 1 times 1 we get 1. Yeah, matrix 0 1, and we get the answer 0 1 for y-axis. Get it? Okay, so next is number 5. Give a point to R3 and use matrix multiplication to determine the result of the points orthogonal projection against. So same as, oh, no, sorry. So there is a, and that a that has point 2 1 and 3. First we need to find projection of xy plane, and we need to multiply the point with standard matrix of xy plane. So this is the standard matrix of xy plane, 1 0 0 0 1 0 0 0 0. Yeah, this, and then we multiplication it. 1 0 0 times 2 is get 2, and 1 0 1 times 1 is get 1, and 0 0 0 times 3 is get 0. So TA equal to 210. Yeah, we got the answer is this. Next is projection of xz plane. Multiplication the point with standard matrix. So the standard matrix of xz plane is this. Yeah, 1 0 0 0 0 0 0 1, and then we multiplication it. 1 0 0 times 2 is get 2. 0 0 0 1 times 1 is get 0, and 0 0 1 times 3 is get 3. So the answer is transform A equals to 2 0 3. Okay. Next is number 6. Give it a point at R2 and constrain the image of the point if it's rotate around the center by a rotating angle. So this is the question, and we answer number A. Theta is equal to 30 degrees that has point 3 minus 2. Yeah. So we multiplication the matrix of, yeah, theta equals to this. 30 degree is this. Cos 30 degree minus sin 30 degree, sin 30 degree, and cos 30 degree. And multiplication with matrix 3 minus 2, and then this is the value of cos minus sin and cos. Now we multiplication 3, yeah, and then with multiplication matrix 3 and minus 2, and then we, yeah, and this is the conclusion answer. The answer is matrix 3.59 and minus 0.23. Then is the answer of D. Theta is minus 60 degree. That has point 4 and 2. And because this minus or negative angle, so we antonym about the positive angle. So it become minus cos sin min sin and min cos, and multiplication with matrix 4 and 2, and this is the value of minus cos sin and min cos of 60 degree, and multiplication with matrix 4 and 2, and become matrix 0.37 and 2.46. And that's all about number 6. Next is number 8. Give a point at R3 and a scalar k is real number. Use matrix multiplication to determine the image of the point F. A. Contraction with factor k under 1. B. Dilated by a factor k more than 1. And C. Expand the x direction and factor k more than 1 and the compression in the y direction and a factor k under 1. So for this problem we have point, yeah, in R3 is 1, 3 and 2. So the contraction k is equal to a half, because a half is under 1. That is the standard matrix. Sorry. This is standard matrix of second contraction in R3. This k, this diagonal k. So k is a half, and then we need to multiplication it. A half 0 0 times 1 is a half, and 0 a half 0 times 3 is 1.5, and 0 0 a half point 0 0 0 a half times 2 is 1, and then we get the answer is matrix a half 1.5 and 1, or this is the in decimal. Dilation in k equal to 3, same as contraction k, this diagonal k. Then we made multiplication it. 300 times 1 is 3, 030 times 3 is 9, and 003 times 2 is 6. So the answer is matrix 3, 9 and 6. So, and then for C, expansion in the x direction and k equal to 2. So this is expansion, and so expansion and compression in R2 and R3 is same. The standard matrix is only the first matrix is k, and the next diagonal is 1. So we get this k is equal to 2, and then 2 0 0 0 1 0 0 0 1, and then we multiplication it. 2 0 0 times 1 is 2, 0 1 0 times 3 is 3, and 0 0 1 times 2 is 2. So the answer is matrix 2, 3 and 2. And then compression in the y direction and k equal to a half. So the difference of in x direction and y direction is the first matrix. Yeah, this is the illustration. and standard matrix. So the first standard matrix is 1 and the next diagonal is k, like this. So k is the a half, so first it's 1 0 0, next 0 half 0 and 0 0 half, and then we multiplication it in 1 0 0 times 1 we get 1, and 0 a half 0 0.3 we get 1.5, and then 0 0 a half times 2 we get 1, and the answer is matrix 1 1.5 and 1. So that's all about my explanation about number 2 3 4 5 6 and 8. That's all about my explanation. Thank you so much.